What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. Networking. This relies on fundamental services that facilitate communication, security, and efficient management of devices in an IPv4 and IPv6 environment. In the CompTIA Network Plus exam, it emphasizes the need to understand and implement these network services. And in this video, we're going to explore dynamic addressing, name resolution, and time protocols, providing a thorough guide to their implementation. All right, so let's go ahead and talk about dynamic addressing. So dynamic addressing, this allows network devices to obtain an IP address automatically, reducing manual configuration errors and improving scalability. And the two primary methods are DHCP for both IPv4 and IPv6, and stateless address auto configuration for IPv6. So let's go ahead and talk about DHCP. So DHCP, this dynamically assigns IP addresses, subnet masks, gateway addresses, and DNS settings to devices. And it operates using a lease-based system, ensuring addresses are reclaimed but no longer in use. And here are some of the key concepts of DHCP. So you have reservation. So a DHCP reservation, this assigns a specific IP address to a device on its MAC address. And this is useful for devices requiring static IPs such as servers and printers. Then you have a scope. So a scope, this defines the range of IP addresses available for distribution. And each subnet typically has a unique DHCP scope. Next, you have what is called the lease time. So the lease time, this determines how long a device retains its assigned IP before requesting renewal. And shorter leases, they work well for high turnover environments like public Wi-Fi, while longer leases are better for stable networks. Then you have DHCP options that provide additional configuration parameters such as the default gateway, DNS servers, NTP servers, and PXE boot, which is used for network booting. Then you have the relay or IP helper. So in larger networks, DHCP relay agents, which are also called IP helpers, they forward DHCP requests between subnets, allowing a centralized DHCP server to serve multiple networks. And then you have exclusions. So DHCP exclusions, they define addresses within the scope that should not be assigned dynamically. And these are typically reserved for static assignments. All right, next let's quickly talk about the stateless address auto configuration, or SLAC. So SLAC, this is an IPv6 exclusive method allowing devices to configure themselves automatically, and it relies on router advertisements from a router to assign a unique global unicast address without requiring a DHCP server. And SLAC, this operates by combining the network prefix with a host interface identifier or some randomly generated ID. All right, so let's move on and talk about name resolution. So this maps human readable domains to an IP address, and the two primary methods are DNS and host files. So let's talk about DNS, which is the domain name system. And this translates domain names to IP addresses using a hierarchical structure. And DNS records, they store essential information about domains. And here are some of the record types. So you have what is called an A record, and this maps a domain to an IPv4 address. You have what is called a quad A record, and this maps a domain to an IPv6 address. You got the CNAME record. This creates an alias for a domain. You got the mail exchange record, and this defines mail servers for email routing. You have what is called a text record. This stores arbitrary text, which is commonly used in SPF or Sender Policy Framework, and DKIM, which stands for Domain Keys Identified Mail. You have what is called the NS record, or the name server record, and this identifies authoritative DNS servers for a domain. And then you have the pointer record, and this performs reverse lookups, mapping an IP address to a host name. Then we have various DNS zone types. So the first one is called a forward lookup zone, and this resolves domain names to IP addresses. You have what is called a reverse lookup zone, and this resolves IP addresses to domain names. Then you have what is called an authoritative versus non-authoritative DNS, and the authoritative DNS servers store original domain information, while the non-authoritative DNS server caches query requests. Then you have the primary versus secondary DNS, and the primary DNS server holds the original records, and the secondary DNS server provides redundancy through replication. And then we have what is called a recursive DNS query, and this is when DNS resolvers fetch records from authoritative servers if they don't already have cached data. And then you have what is called the secure DNS implementation. And the first one is the domain name system security extension. So this adds cryptographic signatures to DNS records, preventing spoofing. And then we have what is called DNS over HTTPS and DNS over TLS. And this encrypts DNS queries to prevent eavesdropping and tampering. And then we have what is called a host file. So the host file, this is a local text file that maps IP addresses to domain names. Although largely replaced by DNS, it is useful for testing and overriding domain resolutions locally. All right, next let's talk about time protocols. So accurate time synchronization, this is crucial for authentication, logging, and network operations. And the main time synchronization protocols include NTP, PTP, and NTS. So let's go ahead and talk about them. So the first one is NTP, or Network Time Protocol, and this synchronizes clocks across devices using a hierarchy of time sources, and it ensures accurate timestamps for network logs, authentication, and scheduling. Then you have what is called PTP, or Precision Time Protocol, and this provides higher accuracy than NTP, making it ideal for financial transactions, industrial automation, and telecommunications. And it synchronizes devices within nanoseconds by accounting for network latency. And finally, you have what is called NTS, or Network Time Security. And this is a security extension for NTP that protects against spoofing and man-in-the-middle attacks. And it uses transport layer security to ensure time synchronization integrity. All right, so in conclusion, proper implementation of IP version 4 and IP version 6 network services. This ensures efficient device communication, security, and network management. DHCP, this automates IP assignment, while Slack provides a lightweight alternative for IP version 6. DNS ensures seamless name resolution with secure implementations like DNS security and DOH/DOT enhancing security. And finally, time protocols like NTP, PTP, and NTS, they maintain network synchronization, which is crucial for security and logging. So mastering these concepts is essential for networking professionals preparing for the CompTIA Network Plus exam and real-world network administration. All right, now with all of that being said, let's do some check on learning. So the first question is, a network admin wants to ensure that specific devices always receive the same IP address from the DHCP server. Which DHCP feature should be used? Would this be the DHCP lease time, scope, reservation, or relay? And the correct answer is the DHCP reservation. So a DHCP reservation, this ensures that a specific MAC address always receives the same IP address from the DHCP server. And this is commonly used for network devices like printers and servers that require a constant IP address. Other DHCP features like lease time, they determine how long a device can hold an IP address before renewal. Scope defines the range of available IPs. And relay, this helps forward DHCP requests between different subnets. Next question. Which of the following DNS record types is used to map an IP version 6 address to a domain name? Would this be A, MX, CNAME, or Quad A? And the correct answer is this will be a Quad A record. So this is used to map a domain name to an IP version 6 address. And this is similar to an A record, which maps a domain name to an IP version 4 address. Other DNS record types include the mail exchange for email servers, the canonical name or the CNAME for aliasing one domain to another, and the name server for identifying authoritative DNS servers. And our final question, which protocol is used to synchronize time across network devices with high accuracy? Would this be DNS security, NTP, DOH, or Slack? And the correct answer would be NTP, or Network Time Protocol. So this is used to synchronize time across network devices with high accuracy, ensuring that all systems on the network have the correct time. Precision Time Protocol, this offers even greater precision for time-sensitive applications. DNS security, this secures DNS transactions. DOH, which is DNS over HTTPS, this encrypts DNS queries. And Slack, which stands for Stateless Address Auto Configuration, this is used for automatic IP version 6 addressing.